Welcome to all, dear students. Now I am going to explain the problems and module relates to the topics regarding JEE Mains examination in subject physics. First one is physical world, second one is straight line motion, third one is motion in a plane. So out of all these three chapters here, under module we selected 27 to 26 questions are there. So now I am going to explain one after another regarding these module questions. So first one, this first one here, the percentage of errors in the measurement of the mass and the speed are 2% and 3% respectively. How much will be the maximum error in the estimate of kinetic energy obtained by measuring mass and speed? So percentage of errors in the mass and speed are given in the data. So what is the basic equation for kinetic energy here? Kinetic energy is equal to half mv square. So here percentage of error in kinetic energy is delta E by E into 100 is equal to delta M by M into 100 plus 2 into delta V by V into 100. So this percentage of error in the mass is given as here 2% plus percentage of error in the speed is given as here 3%. So 2 into 3. So it is 2 plus 6, that is 8%. If mass and speed percentages are given in the data as 2% and 3%, then the percentage of error in the measurement of kinetic energy according to given data is 6%. So answer is B. Answer is B for question number 1. Next question. Question number 2. A boat is traveling due east at 12 meters per second. A flag on the boat flaps at 53 degree north of west. Another flag on the shore flaps due north. Then, according to options, speed of wind with respect to ground is given. Speed of wind with respect to ground in the second option is given as 20 and speed of wind. So, we have to find speed of wind with respect to ground and speed of wind with respect to boat, that we have to identify. So, in this case, boat is traveling due east. Boat is traveling towards east with speed 12 meters per second. And a flag on the boat flaps at 53 degree north of west. So it is north, this one is west, this one is south. So in this case a flag, this is the flag. So this flag flaps at 53 degree north of west. Okay, see here 53 degree north of west it is. So here this is the 53 degree. This is the flag, one flag on the boat here. Another flag is on the shore. Another flag is on the shore. It is on the shore. It is this flag like this. Another flag on the shore flaps due north here. So why it is the reason for this flag flaps in the direction of 53 degree with respect to west? So it is due to wind. So indirectly the velocity of the wind with respect to boat is given. So this direction represents velocity of the wind. This is velocity of the wind with respect to boat is given as V. So in this direction, this is the velocity of the boat. In this direction here, this angle is 53 is given in the data. So velocity of the wind with respect to boat represents the direction of fluttering of this flag. So therefore, velocity of the wind with respect to boat is supposed to be V. Then its component along west direction is equals to the velocity of the boat in eastward direction. Therefore, what is the component of this velocity of wind with respect to B? It is V cos 53 degree. V cos 53 degree is equal to VB. That implies V into cos 53. What is cos 53? Sin 37 is equal to cos 53. So sin 37 is 3 by 5. So cos 53 is also 3 by 5 is equal to VB. So from this V is equal to V into 3 by 5 is equal to VB value is given as 12. So, from this 3 4 times it is V equal to 20 meter per second. So, velocity of the first flag with respect to boat is calculated, velocity of the wind with respect to boat is calculated as 20 meter per second. Okay. So, now here what we want, so this represents, this is the component of velocity of the, flag with respect to wind is calculated. So, in this direction, the component of this one indicates, the another flag which is at shore. So, component of this V in this direction is, here it is V sin 53. V sin 53 is the velocity of the another flag which flutters in northward direction. So, what is the velocity of the flag which flutters in northward direction? That will represents the direction of the wind flow. So, boat is moving towards eastward direction, wind is supposed to move along northward direction. Then at shore, another flag at rest flutters in northward direction, means indirectly it indicates the velocity of wind. So, due to that here this flag on the boat flutters in a direction 53 degree with westward direction. So, this is I considered velocity of the wind with respect to boat, or velocity of the boat with respect to wind in this direction as V. So, the component of this V in westward direction is equal to the magnitude of velocity of boat in eastward direction. So, that value here it is V into cos 53 value is equal to 3 by 5, that is equal to sin 37, that is given as 12. So, from this velocity of the here wind with respect to boat I calculated as 20 meter per second. But what we want, we have to calculate absolute velocity of the wind, that it indicates that it was indicated by here the flag at shore. So, according to given data, the flag at shore flutters in a direction towards north. So, due to that it indicates the absolute velocity of the wind. So, that direction, the component of this velocity V, that will give the absolute velocity of the wind. So, that is given as absolute velocity of the wind is given as, here it is velocity of the flag in the northward direction at shore. So, therefore, velocity of the flag in northward direction at shore is equal to V is 20 into sin 53. Cos 53 is 3 by 5, sin 53 is 4 by 5. So, 4 times, that is 16 meter per second. 16 meter per second is the velocity of the wind in northward direction. So, answer is speed of the wind with respect to ground. Speed of the wind with respect to ground is 16 meter per second is the answer. Speed of the ground with respect to wind is ground is 16 meter per second. So, what is the velocity of the wind with respect to boat? That is 20 meter per second. So, velocity of the wind in the northward direction, is absolute velocity. That value is 16 meter per second with respect to wind. So, answer for question number 2 is speed of the wind with respect to ground is 16 meter per second is the answer for question number 2. Next question. Question number 3. A paper helicopter with rotor radius R, weight W is dropped from height H in air with a density rho. Assuming that the helicopter quickly reaches the terminal velocity, the function of the time of flight t can be found in the form t equal to some function is given, k into h to the power alpha into r to the power beta into rho to the power delta into w to the power omega, where k is an unknown dimensionless constant. Alpha, beta, delta and omega are the constant exponents to be determined. Then find the value of alpha. So, a paper helicopter This is a paper helicopter with certain rotor of radius small r is given, falls at certain height, great height. So after attaining, when it falls from great height, after attaining terminal velocity Vt, after attaining some terminal velocity Vt, now what we want here, after attaining terminal velocity, quickly attaining terminal velocity, the function of time of flight, function of time of flight can be found in the form of t equal to k into some function is given. So here so in this case, what is the distance covered by this helicopter in a given time interval? Distance, suppose helicopter covers a distance s with this speed terminal velocity in a given time interval t. Then distance is equal to Vt, terminal velocity into t. So from this here s is suppose it is h is equal to v into t. So what we want here, see, t equal to some h, t and h relation we want. So h is directly proportional to t power 1 or t is directly proportional to h power 1. So here according to given data, here t directly proportional to h alpha is given. H alpha or h beta here, h alpha is given in the data. H alpha is given. So where alpha is equal to 1. So here t is independent of the remaining quantities according to given data. What are the quantities are there here? It is remaining quantities are h, r, rho and w are given. So according to given data, for a paper helicopter with rotating radius that is indirectly is having some rotor with certain radius, all are given to confuse the student only. So when it falls, when rotates and falls slowly, so after attaining certain height, then it moves down with the terminal velocity. Let it travels for t seconds. Then the distance covered by the helicopter is supposed to be h in a given time interval t. Then because when it attains terminal velocity, it moves down with constant velocity. So when body moves with constant velocity, what the distance covered by the body in t seconds is displacement equal to velocity into time. The displacement I have taken as h and that velocity is Vt into t. So from this, according to given data, t directly proportional to h to the power alpha. Here t directly proportional to h to the power 1. From that, by comparing this equation with the given standard form, here then we get alpha value as 1. So answer for this one, alpha is equal to plus 1. So answer is D for question number 3. So determine alpha value. So what is the value of alpha? Alpha equal to 1 is the answer for question number 3. Next question. Question number 4. An object is projected from certain height at an angle 45 degree with horizontal. It lands at a horizontal distance capital from the point of projection. The velocity of the projection should be, so an object is projected from height h at an angle 45 degree with horizontal. So at certain height h, an object is projected with certain velocity u at an angle 45 degree with the horizontal. Then it falls like this. It falls. So here, or it falls at this point here, we don't know. It lands at a horizontal distance capital from the point of projection. It lands at a distance capital from the point of projection. This is the distance. R is given. Then the velocity of the projection should be. That we want. So in this case, what is the component of this one here? It is along horizontal direction, it is projected with velocity u cos 45. Indirectly along vertical direction, it is to be projected with velocity u sin 45. So in this case, here what we want here, the velocity of the projection. Velocity of the projection means indirectly here, let it reaches this point C when it is projected from point A. So at this point, I considered the horizontal displacement covered by this projectile is x, and vertical height by this one. What is the vertical height here? This distance is x. The vertical displacement covered by this projected body is, suppose, h. So it is h. So, or suppose it is h1. Then this one is to be taken with respect to this point. With respect to this point here, the coordinates are minus h1, comma r are the coordinates of this point. Minus h1, comma r are the coordinates of this point. So this r can be taken as x coordinate here. Suppose at this point h equal to 0, x coordinate is r. At this point the x coordinate is x and y coordinate is minus h dash, I considered. Now this is the velocity u, angle 45 degree. This component of velocity is u cos 45. So when body is projected certain height with a horizontal velocity u cos 45, let it reaches this point here. Let it reaches this point r. This distance is supposed to be r. So in the absence of gravity, here this body is supposed to move along this path. So I considered any one of the point. Here. This point is. So at this point here, the distance is the coordinates of this one. This will becomes range. But this is at certain height. So what point of projection at this point, it is having some coordinates. So what is the basic equation for the path of the projectile here? Y equal to x tan theta minus gx square. Y equal to x tan theta minus gx square by 2u square cos square theta is the basic equation. But here I am going to calculate the vertical displacement of the particle. So what is the vertical displacement of the projectile here? Y equal to u sin theta into t minus half gt square. In vertically downward direction. So u sin theta. What is u sin theta? It is in this direction. It is. So in this direction, here vertical component of velocity u sin theta. So along horizontal direction, x equal to u cos theta into t. U cos theta into t is the horizontal displacement covered by the body. But there is no horizontal acceleration. In this case, we have to consider y and x values. So we know that the basic equation for the displacement of y is equal to this u into t minus half gt square, in place of u as uy. So this u into t is written as, here it is x minus half into g into, in place of t I write here basic equation here x by u whole square is equal to y. But after t seconds, the vertical displacement is minus h is equal to x is r minus half g into, in place of x square I write r square by u square. So after doing calculation, we get velocity u as u equal to square root of r square g by r plus h. So u equal to square root of r square g by r plus h. So these are the general equations I have written. But here what is the vertical displacement of the body after t seconds when it is projected with the velocity? It is also here horizontal direction. So it is also horizontal direction of the velocity component is ux. Here it is ux, here it is ux. So but horizontal direction velocity component is ux into t, that will give horizontal displacement. So here it is ux. Ux is the u cos 45. So u cos 45, that means here u square into ux square here. But ux, we know that ux is equal to, what is ux here? U cos 45. So u cos 45, here cos 45 is also there. So ux is, where ux is equal to u into cos 45, u by root 2. You substitute ux as u by root 2, then finally you get u value as square root of r square g by r plus h is the answer for this question. So answer is root of r square g by r plus h. Do the calculation. Okay. So when body projected certain height, it strikes the ground having range r. Indirectly, it is projected with horizontal velocity as u cos 45. So during its path, I considered one point of coordinates x and y, where x is the range and y is the vertical displacement is minus h, because this is the point, this suppose this point, at this point finally these coordinates are minus h comma r. So y coordinate is taken as minus h, x coordinate is taken as r. Lastly I substitute like that. So meanwhile in this case simply I have written the equation for y equal to here it is u into t minus half g into t square. In place of t I write here horizontal displacement by horizontal component of velocity. In place of y I replace it as minus h. In place of t I replace it as x by ux. Ux again I replace it as u cos 45, that is u by root 2. So after substitution of these two, we get u equal to root of r square g by r plus h is the answer for question number 4. So answer is A for question number 4. Next question. Question number 5. An experiment measures quantities A, B, C and x is the value calculated by the relation AB by C cube. If the maximum percentage of error in A, B, C are 1, 1 and 2% respectively, then what we want here? Then the maximum percentage of error in x to be calculated. See the options here. Error in x may be 10, error in x may be minus 4%, error in x may be 8%, like that in the options it is given. So you have to calculate the percentage of error in x. So what is the basic equation for x here? According to given data, AB by C cubed is given. So x is equal to AB by C cubed. So percentage of error in x is equal to delta x by x into 100 is equal to delta A by A into 100 plus delta B by B into 100 plus 3 into delta C by C into 100. So all the values are given in the data. Delta A by A into 100 value is given as, that value is 1 and B value is 1, C value is, here it is 2. So 1 plus 3 into 2. So that equal to 6 plus 7 plus 1, 8%. So percentage of error in x is 8% is the answer. So when the percentage of errors in the measurement of A, B, C values are given in the data, how you calculate the percentage of error in x? So percentage of error in x is written as, here delta A by A into 100 plus delta B by B into 100 plus 3, this power is 3 here. Even though it is in denominator, error always to be added. So therefore 3 into delta C by C into 100. So by substituting these values, we get percentage of error in x as 8%. Okay. So answer for this one is D. The maximum percentage of error in the x is 8% is the answer for question number 5. Next question. The block was observed to move on a straight line uniformly. It displaces 10 centimeter in 2 seconds. It displaces 10 centimeter in 2 seconds. The straight line has calibration of 1 millimeter. The stopwatch is used to measure time, has a least count of 0.1 second. Using this data, its speed is calculated. Now the displacement of the block is calculated for next 10 seconds using same stopwatch. The absolute error in the calculated value of displacement will be that we want. So a block was observed to move along straight line uniformly. So it covers 10 centimeter. It covers 10 centimeter in 2 seconds. The straight line has calibration. The least length of the measurement of the straight line is this is the calibration. So on straight line, this calibration is having least value, it is 1 millimeter. That is indirectly delta L is given. The least measurable value of length is given as 1 millimeter. That is 1 millimeter. That is 0.1 centimeter. That is delta L. And the least count of time is given as 0.1 second. So delta T is given 0.1 second. Delta T is given as 0.1 second. Now what we want? Using this data, its speed is calculated. So what is the basic equation for speed? So speed is equal to distance covered by time. So percentage of speed is delta V by V into 100 is equal to delta L by L into 100 plus delta T by T into 100. So this value delta L by L, delta L value is given as, what is delta L here? Delta L value is 0.1 centimeter by, in centimeters it is given. Okay, by L value, what is the L value here? 10 centimeters. 10 centimeter into 100 plus delta T 0.1 second by 2 seconds. 2 seconds into 100. See here it is 10 into 1 plus here 50, it is 5%. So total 6%. So the percentage of error in the measurement of velocity as 6% by assuming the least count of time is 0.1 second and the least count of length measured by moving a block along straight line of least calibration of its length is 1 millimeter is here 6%. So indirectly the percentage of error in the measurement of velocity by using the data is calculated as 6%. Now, so what is the next point here? Out of this one, now the displacement of the block is calculated for next 10 seconds. I calculated that one for, here it is 2 seconds and next 10 seconds here it is. Only 2 seconds here. See here, for 2 seconds I calculated the velocity. For next 10 seconds. What we want? Distance covered. Distance is equal to velocity into time. The percentage of error in the measurement of distance covered is equal to delta V by V into 100 plus delta T by T into 100. So what is delta V by V into 100? Already the percentage of error in the measurement of velocity is calculated as 6%. 6% it is. Plus, that is 6. Percentage is 6. Here plus delta T value 0.1. For next 10 seconds it is to be taken. Here it is taken as 2 seconds. For first 2 seconds I calculated the percentage of error in the velocity because it continues to move uniformly along same line. So percentage of error in the velocity is same. So due to that I considered here same velocity of, in terms of percentage of error as 6 into multiplied by 100. So that is here 10 plus 6 it is. So 0.1 by this value is 10 seconds here. So 10 we get it is 7%. This is the percentage of error in the distance measured as block moves along straight line uniformly. So from this we want what the error in the distance 7%. So 7 by 100 into this value is S. So for S here for 10 seconds, what the distance moved here? See the question here. So it is for 10 seconds, for 2 seconds it covers 10 centimeter distance. So for next 10 seconds, 5 times. For next 10 seconds, the distance moved is here 50. Therefore 10 by 100 into 50. Here S is the total distance moved in 10 seconds is 50 centimeters. So therefore 7 by 100 into 10 because I consider this one in centimeters. Here in centimeters. Okay. So do that here it is 3.5 5 centimeter is the 3.5 centimeter is the error in the measurement of distance covered by the block moves uniformly along a straight line. So, answer is 3.5 centimeter is the answer for question number 6. So, answer is A. So, this is another standard model question regarding errors and measurements. Okay. So, first what I considered here, I considered the least measurable value of time is 0.1 second and the least measurable value of length is 1 millimeter, that is 0.1 centimeter. I considered the error for first 2 seconds regarding velocity, that is percentage of error in the measurement of velocity based upon this data as 6%. Later, here for next 10 seconds, the distance covered is, for first 2 seconds it covers 10 centimeter distance, then for next 10 seconds means 5 times. So, the distance becomes 5 times because it moves uniformly on a straight line. So, the distance covered by it is 50 centimeters. So, therefore, distance covered is 50 centimeters, but I am going to calculate the error in the measurement of distance by using the data. So, error is velocity into time. So, percentage of error in the measurement of distance is delta S by S is equal to delta V by V into 100 plus delta T by T into 100. So, this is given, this is already calculated as 6 because here it moves with uniform speed. So, that is given indirectly. So, I calculate this percentage of error as it is, I have written as 6 plus delta T by T into 100 is 0.1 by 10 into 100. From that, after calculation we get percentage of error in the measurement of the distance covered by the block is 7%. Now, what is the error? Error in the measurement of distance covered by the block is 7 by 100 multiplied by total distance moved by the block in that given time interval of 10 seconds. That is 7 by 100 into 50, that we can get 3.5 centimeter is the answer for question number, here it is 5. So, answer is A for question number 6. Question number 6, answer is A. Next question. Question number 7. A particle moves along circle with constant angular speed omega. Its displacement with respect to this position of the particle at time t equal to 0 is plotted against the time. The graph would look like. So, this particle moves along circle with constant angular velocity. Its displacement with respect to the position of the particle at t equal to 0 is plotted against the time. So, in this case, when particle moves along circular path, suppose this is the initial position of the particle at t equal to 0. After t seconds, that particle moves from A to B. So, with respect to center, this is the angular displacement made by the particle theta. This is the radius of the path of the particle. So, when it reaches from A to, when it reaches B from A, then this is the displacement made by the particle. So, it is the displacement. This angle is 90. This angle is theta by 2. So, displacement is AB. So, displacement is AB. S is equal to, when particle subtends, moves on a arc, subtends an angle theta at center, all of you know the displacement made by the particle is 2r sin theta by 2. 2r sin theta by 2. So, when it moves with constant angular velocity, angle made by the particle theta is equal to angular velocity into time. So, therefore, it is 2r sin into, instead of theta I write omega t by 2. So, this is the displacement of the particle in a given time interval t when it moves on circular path. So, S is equal to 2r into sin omega t by 2. Indirectly, the displacement which varies in accordance with the time is in the form of sine function. So, here according to given options, see the options here. So, first one is circular path, second one is circular path, third one is orally it is given as sine curve. Fourth one is some other curve having some slopes are given. So answer is C, because it is given, but it is not the actual sine curve here. So it is orally given as sine curve. So for question number 7, here answer is C, because the displacement made by the particle is 2r sine theta by 2. The theta is omega t by 2. Omega t by 2 is the answer. So answer is C for question number 7. Question number 8. A screw gauge has some zero error, but its value is unknown. So indirect is having some error. It is having some error, not equal to 0. Okay, 0 error means it is having some error. Whether it may be positive or negative, we don't know. Okay, but its value is unknown. That is given the data. We have two identical rods. Two identical rod. One rod of length, suppose L. Another rod of length is also L. Okay, when first rod is inserted in the screw of the screw gauge, the state of the instrument is known by diagram 1. So indirectly it is a pitch scale, it is head scale. So we know that in screw gauge here the total reading is equal to pitch scale reading plus head scale reading into least count. So generally, because there is no limitations of least count is given, so generally for general screw gauge used in the laboratory, generally we use whose least count is 0.01 centimeter. 0.01 centimeter is the least count of screw gauge. So least count of screw gauge generally we use 0.01 centimeter, because other specifications are not made in this problem. See, here it is given. So indirectly it is given, because 100 circular scale divisions is equal to 1 millimeter. 100 circular scale divisions is equal to 1 millimeter. So indirectly here, so on head scale there are 100 divisions, and on pitch scale the length of each division on pitch scale is 1 millimeter. So indirectly it represents 0.01 centimeter or 0.001 millimeter. So with the help of this screw gauge, we can measure length accurately up to 1/1000 part of the millimeter. So what is the sensitivity of this screw gauge according to given data? We can measure length accurately up to 1/1000 part of the millimeter. That is the sensitivity of this screw gauge. So on that basis here this problem is designed. Okay. So least count is taken as 0.01, say either centimeter or 0.001 millimeter. Now what we want? When first rod is inserted, then this is the reading. So what is the reading here? So it is 0th division. This is 1, 2. So 2 is the reading of the pitch scale, and head scale reading is, here it is 12 is given. Head scale reading is 12 is given. So therefore length is this one, L plus some error is there. X is equal to 2 plus 0.01 into 12, that equal to 2.12 is equal to L plus X. The X is the error. Having some zero error in the screw gauge according to given data. So according to first diagram, what is the equation here? L plus X is equal to 2.12 centimeters. Next, see second diagram here. When both rods are inserted together in series, then the state is shown by the diagram. So when these two rods are inserted in series, then the total length of measurement is L plus L, 2x. Error is some x. So on that basis here 2L plus x is equal to, now what is the pitch scale reading here? 1, 2, 3, 4. So pitch scale reading is 4 plus 0.01 into head scale reading is, here it is 10. So here 10 is the head scale reading. That equal to 2L plus x is equal to 4.10. 4.10 is the equation regarding the second arrangement. Now what we want here? Error we want. So we have to eliminate L. So it is L plus x initially 2.12. I multiplied this one with 2. We get 2L plus 2x is equal to 4.24, equation 3. I multiplied this one with the 2, then we get 2L plus 2x equal to 4.24. So here 2 is subtracted from 3. 2 is subtracted from 3. 3 minus 2. Then we get 2L, 2L gets cancelled. 2x minus x is equal to 4.24 minus 4.10, that is 0.14. So error is equal to 0.14 in millimeters or centimeters. Here it is in millimeters. It's 4 millimeter. It is in millimeters. Error is 0.14 millimeter. So error is 0.14. Correction is minus 0.14. If you take error as 0.14, correction will be minus 1.14 millimeter. But we added, by what we added, that x is added to that value. So error is negative. So answer is error is negative, means minus 0.14 millimeter is the error. So here I considered 0.14 millimeter as error, I added, but correction is minus. But there it is added, x value is added to that 2L plus x something or L plus x something. There some error is added, means indirectly correction we considered. So due to that the error is negative. When we are adding something, error is added to the at observed value, then indirectly actual error is called negative. So error is minus 0.14 millimeter is the answer. So answer is D is the answer for question number 8. Minus 0.14 millimeter is the answer. So what is the basic equation for the length of this rod inserted between the screws of the screw gauge here? It is total reading equal to pitch scale reading plus head scale reading into least count. So least count according to this given data is calculated as 0.01 centimeter. That is 0.001 millimeter, but in centimeters we want, okay, right. So that is 0.01 into 12 for first diagram and 4 plus 0.01 into 10 for second diagram. So from this we get L plus x equal to 2.12 and 2L plus x equal to 4.10. So we want error. So in order to eliminate L, here I multiplied the equation 1 with 2 on both sides, and 2 is subtracted from equation 3. From this we get error as 0.14. But in the equation 2L plus x, so I am adding x value to 2L. So whenever this error is added here for accuracy of the value of the measurement here, if error is negative, then correction is to be added. So I added here x. So indirectly error is negative. So answer is minus 0.14 millimeter is the answer for question number, here it is 8. Question number 8 answer is D, minus 0.14 millimeter. Next question. A physical quantity A is depends on another 4 physical quantities P, Q, R and S given as A is equal to root of PQ by R square into S cubed. The percentage of errors in the measurement of P, Q, R and S are 1%, 3%, 5% and 0.33% are given respectively. Okay, then find the maximum percentage of error in the measurement of A that we need. So delta A by A into 100 is equal to, for P it is under root, so half into delta P by P into 100 plus, for Q is also under root, so it is half into delta Q by Q into 100 plus, for R it is R square is there, so 2 into delta R by R into 100 plus S cubed is there, 3 into delta S by S into 100. Okay. So here by substituting the percentage of errors in P as 1 and Q as 3% and R as 0.5% and S as here 0.33%, after calculation we may get answer as here 4%. C is the answer. You substitute the value. This value is 1. This value is given as 3 and this value is given as 0.5 and this value is given as 0.33. So 1 by 2 into 1 plus 1 by 2 into 3 plus 2 into 0.5 plus 3 into 0.33, you take 1. So after calculation, we get percentage of error in the measurement of quantity A is 4%. So answer is C for question number 9. Question number 10. Which of the following is the most precise device for measuring of length? Which of the following is the most precise device for measuring of length? See the options. Vernier calipers with 20 divisions on the sliding scale. 20 divisions. Generally, vernier calipers is made with 10 divisions. So 10 divisions means here 1 millimeter is subdivided into 10 equal divisions. That is in the form of vernier scale. So that is a precise device for calculation of length up to 1 by 20. 1 by 20th part of the centimeter only. Next, screw gauge of pitch 1 millimeter and 100 divisions on the circular scale. So this is having precise indirectly. It is having least measurable length up to 1 by 100th part of the millimeter. So 1 by 100th part of the millimeter. So this is having precise value. Precise value indirectly. The most precise value means most least measurable value by this device is 1 by 20th part of the, here it is 1 centimeter. Okay, according to given option here. Next, an optical instrument that can measure the length up to which the wavelength of the light. So wavelength of the light is in the order of 10 to the power minus 8 meters. These are in the order of 10 to the power minus 2, minus 4 meters here, 10 to the power minus 3, minus 5 meters here in this second case. So due to that here, it is the highly sensitive instrument to measure length in the order of wavelength of light. So for this device, precision is for this device here, it can measure wavelength accurately up to 10 to the power minus 8 meters order. For that reason, this instrument is said to be most precise device when compared to the first three. Fourth one, precise cannot be changed by changing the instrument. Yes, precise indirectly, precision, not precise here. Precision can be changed. What is precision here? Precision means here for measurement values, if the difference is very small, suppose if you conducted one experiment and taken for 10 readings, for each and every reading you got the result. That result values are very close to each other. Then that device is said to be most precise device when compared to other one. If the difference in the results are very large, considerable in different way. So that device is said to be not so precise when compared to the earlier device. So in this case here, if this instrument is changed, automatically this precision, the precision will also change because the difference in the results, or difference in the final calculation of the concerned physical quantities will be slightly the difference is different for different instruments. Due to that, the precision is different for different length or time or any other quantity measurement instruments. So due to that, it is also wrong. So A, B, C, out of all this, this instrument is having C. This instrument is having said to be more precise device when compared to the given 4 options. So answer is C. Next question. An object is released from rest. Use G equal to 2h by t square to calculate acceleration due to gravity in the 2 experiments. Here T1 is given as 0.781 plus or minus 0.002 seconds and H1 equal to 3 plus or minus 0.003 meter. Here for second instrument experiment 0.551 plus 0.002 seconds, H2 is 1.5 plus or minus 0.003 meters. Then the values of G from the experiments are. So what is G value is given? G is equal to 2h by t square. From this here we have to express the answer in terms of its precise value and error. So therefore G to be expressed as G plus or something, plus or minus some error. So what is the error here? How you calculate error? Delta G by G equal to 2 is number. So H and T are variables according to given data. So therefore it is delta H by H plus, for T square it is 2 into delta T by T. So this is the fractional error in G value. We want delta G. Delta G equal to G into delta H by H plus 2 into delta T by T. So these H values are different for different experiments. These T values are also different for different experiments here in this case according to given data. So for two different experiments, H and T values are given differently and delta H and delta values are given differently. So due to that we get delta G values are also different for these two experiments. First we calculate G value, absolute value. Then we calculate error in G value by using this relation. We can calculate absolute value by using this relation. By using this relation we can calculate error in G value. Okay. So G1 is equal to 2H1 by T1 square. That equal to 2 into what is H1 value? Here H1 value is given as 3 and T1 value is given as 0.781. It is 3 by 0.781 in seconds whole square. So do the calculation. So after calculation we get G1 value as 9.84 meter per second. Do the calculation here. Okay. 2 into H1 is 3 by 0.781 whole square. Next, what is delta G1? Delta G1, what is the basic formula for delta G1 here? G into delta H by H plus 2 into delta T by T. So therefore G1 into delta H1 by H1 plus 2 into delta T1 by T1. That equal to G1 value is 9.84 into delta H1. What is delta H1 here? Delta H1 is equal to 0.003. 0.003 by 3 plus 2 into delta T1. Delta T1 value is 0.002. 0.002 by T1 value. T1 value is 0.781. 0.781. Do the calculation, then you get a delta G1 value as 0.007. 0.007. 0.007 s meter per second square. Okay, like that we can calculate G1 and delta G1 value. Similarly, you calculate G2 value by taking 2H2 by T2 square and delta G2 value as G2 into delta H2 by H2 plus 2 into delta T2 by T2. Then G2 value after calculation 2H2 by T2 square. Do the calculation and delta G2 value as G2 into delta H2 by H2 plus 2 into delta T2 by T2. So do the calculation. After calculation you get G value as 9.88 meter per second square and delta G2 value as 0.09 meter per second square. Okay, do the calculation based upon these values. So from this what is the representation of value of G along with error? So 9.84 plus 0.07 meter per second square, and for second one 9.88 plus or minus 0.01 meter per second square. So answer is B for question number 11. Answer is B for question number 11. So like that, here what I considered here, G equal to 2H by T square is given. So from this I calculated fractional error in G value. From that I calculated delta G value. So for absolute value I substituted H1. For G1, H1 and T1 values, H1 and T1 values. and for G2 value H2 and T2 values, H2 and T2 values here, okay, 0.551, okay, for T2 values. So you do calculation, okay. After that we get delta G1 and delta G1, G2 and delta G2. So here finally the answer for this question after calculation, here it is 9.84 plus or minus 0.07 meter per second square, and for second experiment here it is 9.88 plus or minus 0.09 meter per second square is the answer for question number 11. One of the standard model question it is, but it seems to be little bit calculation oriented model, okay. It will take a little bit time, okay. Be perfect regarding one numerical decimal oriented calculation. So out of all 25 questions in JEE mains level examination, 3 or 4 such questions may be given, okay, that are typical numerical decimal oriented calculations. Next question. The range of the projectile is defined as r equal to u square sine 2 theta by g. It is observed that if a small uncertainty is there for any angle of projection, then result of range will also then, not then here, it is then result of range will have an uncertainty. Compare uncertainty for theta 1 value and theta 2 values are given for the given 4 options. Compare uncertainty for this angle of projections. So here there is uncertainty is observed in the measurement of the angle of projection theta. So uncertainty is in theta. So uncertainty is in theta means indirectly r is directly proportional to sine 2 theta. Automatically uncertainty is also observed in range. Uncertainty is also observed in range. That is, uncertainty is also observed in 2 theta also. So uncertainty is also observed in 2 theta. So what is 2 theta for first case here? 2 theta 1 is equal to 30 into 2, 60 degree, 60 degree plus 0.4 degree, and 2 theta 2 is equal to 90 degree plus 0.4 degree, plus or minus it is, okay, plus or minus 0.4 degree. So these are the uncertainties. Generally for sine function, so for sine function here it is for sine function uncertainty is more. Uncertainty is more nearer to 60 degree than 90 degree. So for any sine function, its uncertainty value will be more nearer to 45 to 60 degree, like that. So when it approaches to 60 degree, uncertainty in sine function is more when compared to if it ranges from 60 to 90 degree. So near 90 degree uncertainty is less when compared to uncertainty near 60 degree. So here uncertainty is more nearer to 60 degree than 90 degree with respect to a sine function. For that reason here uncertainty. So here for first 2 theta 1 uncertainty is more in the measurement of the range regarding the angle of projection 30 degree. So answer is uncertainty is more for angle of projection theta 1, that is 30 degree, because 2 theta value is 60 degree plus or minus 0.4 degree. So for any sine function, for sine function we know that values are having little bit uncertainty when that sine function, then when that angle of sine will approaches to 60 degree, okay. When that value of angle approaches to 90 degree, that's uncertainty near to 79, 78 and 81, 84, 85, like this. Here if angles increase from 65 to 90 or 70 to 90, okay, in that zone here the uncertainty between the values is less when compared to the uncertainty in the values nearer to the angle 60 degree in case of sine function. For that reason, for measurement of range, uncertainty is more in case of angle of projection theta equal to 30 degree when compared to theta equal to 45 degree. So, answer is A for question number 12. So, it is also one of the another important model you have to kept in mind. Okay, this point you have to kept in mind. Right. Next question. A ball is projected so as to clear two walls. The first of height d at a distance c from the point of projection, second of height c at a distance d from the point of projection. Find the correct condition of alpha. Find the correct condition of alpha if the projectile just clears both walls. According to given data, if it clears, if the ball clears both walls of certain heights d and c at a distance c and d. So, these walls are having heights d and c at a distances c and d. So, if this ball clears these two walls, then what we want? At what an angle it is to be projected, that we want. So, here simply we know the basic equation for projectile. When vertical and horizontal displacements are known to you for a projectile during its path, here its basic equation is y equal to x tan theta minus gx square by 2u square cos square theta. So, this is the basic equation for the path of the projectile. Indirectly, here the path of the projectile is nothing but parabola. It is nothing but graph plotted between x and y coordinate of the x displacement and y displacement of the projectile at a different time intervals. That is the nature of the path of the projectile is indirectly called as parabola. Actually, it is the graph plotted between horizontal displacement and vertical displacement of the projectile during its flight. So, that is the projectile here. So, of course, here it coincides with this path also, but graph is also like that. So, actually, we plot a graph like this. That graph is nothing but parabola. This is also in this shape, where alpha is the angle of projection. So, alpha is the angle of projection. For this one, displacement is d, vertical displacement is d, horizontal displacement is c, angle of projection is alpha. So, from this y is written in first case as in clearing the first wall, y is d is equal to x is c into tan alpha minus g into x value is c square by 2u square cos square alpha. In a similar way, for second case it is, this distance is d, y coordinate is c. So, c equal to d into tan alpha minus g into this horizontal displacement is d square by 2u square cos square alpha. This is equation 1, this is equation 2. From this what we want here? Alpha we want. So, we want alpha. What we have to do? So, we have to eliminate here g value. We have to eliminate g value. We have to eliminate, how we have to eliminate g value? So, from equation 1 here d minus c tan alpha is equal to minus gx square by gx square is, that is gc square, g into c square by 2u square cos square alpha, and second one c minus d tan alpha is equal to minus g into d square by 2u square cos square alpha. By dividing 1 with 2, we get d minus c tan alpha by, here it is c minus d tan alpha is equal to c square by d square only. So, by doing cross multiplication and taking tan alpha terms on one side, tan alpha is equal to, here it is c into c cubed minus d into d square d cubed by, here c into d is taken as common factor, c into d into c minus d. So, after doing cross multiplication and taking tan alpha terms one side, remaining terms towards other side, we get tan alpha equal to c cubed minus d cubed by c into d into c minus d in the denominator. But c cubed minus d cubed is written as C cubed minus D cubed is written as tan alpha is equal to C minus D into C square plus D square plus CD by CD into C minus D. So, one C minus D gets cancelled. We get C square plus D square plus CD by, here it is CD. So, up to this point any student can answer. So, after this how we have to proceed? Because we have to calculate the numerical value of alpha. See the options here. Tan alpha is in numerical value, that is either 3 or 3 by 2 are given in the data. So, once again you have to eliminate this C square and this CD. So, here C square plus D square plus CD and CD. So, I have to eliminate CD, C square and D square. So, here in this case I consider the addition of CD. So, for writing of C minus D whole square, C square plus D square minus 2 CD we need. Already CD is there. So, I have to add here 3 CD and subtract 3 CD without changing this value. So, minus 3 CD plus 3 CD. So, minus 3 CD plus CD, it will give minus 2 CD. So, that will give C minus D whole square. That is C minus D whole square plus 3 CD by CD, 3 by CD. So, that is 3 plus C minus D whole square by CD. Indirectly tan alpha is equal to 3 plus something. So, tan alpha is more than 3. So, alpha is more than tan inverse 3. More than tan inverse 3 is the answer. So, like that we have to eliminate this CD term or C minus D term, at least any one of this term. So, here from this we get by adding 3 CD and subtracting 3 CD in the numerator, then this C square plus D square minus 2 CD can be written as C minus D whole square by CD plus 3 CD by CD, that will give 3. So, this value is a little bit more than 3, whatever may be the values of C and D. So, indirectly tan alpha value may be more than 3. So, the alpha is more than tan inverse 3 is the answer. So, for this one tan alpha for question number 13, answer is B. Alpha is tan inverse 3 is the answer. See here, tan inverse alpha is more than tan inverse 3 is the answer. Okay. So, this is the answer for question number, here it is 13.
+2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം.
Check it. Next question. Next question. If the pitch of the screw gauge is 1 millimeter, pitch of the screw gauge 1 millimeter, and there are 100 divisions on the circular scale. While measuring the diameter of the wire, the linear scale reads 2 millimeter, and 40th division on the circular scale coincides with the reference line. Then length of the wire is 6 centimeters. Then the curved surface area of the wire. So this is the wire. So curved surface area. What the curved surface area? That is length multiplied by breadth. Length is 2 pi r into breadth is L. So this is the curved surface area of the curved shape of the wire. Indirectly curved surface area of the wire. So for radius you have to calculate radius on the basis of the first given data, and L is given directly, L centimeter. So how you find radius? So this wire is fitted in between the screws of the screw gauge, and screw gauge of pitch of the screw is given. So what is the least count? Least count is equal to pitch of the screw by number of divisions on head scale. Pitch of the screw by number of divisions on head scale. So pitch of the screw is 1 millimeter by 100, that is 1 by 100 millimeter, that is 0.01 millimeter, that equal to 0.001 centimeter is the least count of the given screw gauge. Now when wire is fitted in the screws of the screw gauge here, so according to given data, pitch scale reading, total reading is equal to pitch scale reading plus head scale reading into least count. So pitch scale reading is 2 millimeters, so you get answer in millimeters. Head scale reading is 40th division coincides with the reference line multiplied by 0.01 centimeters. So here it is 0.01. So from this you get, here it is 2.4 millimeter is the diameter of the wire. So from this radius of the wire is equal to 1.2 millimeter. 1.2 millimeter, that is 1.2 into 10 power minus 1 centimeter. What we want? Curved surface area 2 pi r into L. So 2 into 3.14 into r value is 1.2 into 10 power minus 1 into length value is given as, what the length of the wire? It is 6 centimeters. Length is given as 6 centimeters. Do the calculation. After calculation we get the value 4.53 centimeter square. So 4.53 centimeter square is the answer for question number 14. So the curved surface area of the given wire in between the two screws of the screw gauge is 4.53 centimeter square. We want the answer. So here length is given in centimeter. So we get diameter of the wire as 2.4 millimeters. From that we get radius as 1.2 millimeter. To be converted into centimeter, it is 10 to the power minus 1 into length as 6 centimeters. So we get all the values in centimeters. So that is centimeter square is the area of that curved part of the wire. That is, after calculation you get 4.53 centimeters square is the answer for this question. Next, question number 15. A particle is projected at an angle of elevation alpha. After t seconds, it appears to have an angle of elevation beta as seen from the point of projection. This is the inclined plane. When particle is projected. This is x axis to be considered. This one will be the y axis. When particle is projected like this at an angle. At an angle, here it is angle of elevation is alpha. So by seeing from this point here, its elevated angle is beta. Indirectly, it is given as beta. Elevated angle is given as beta. Elevated angle is given as this one as beta. So this is the elevated angle of this by seeing the path of this projectile with respect to this horizontal line. The angle of elevation is beta as seen from the point of projection. So it is beta is given. Angle of elevation of the inclined plane is given as beta. So angle of projection is beta minus alpha. So what is the time of flight of this projectile? Time of flight of the projectile is equal to 2u sin, in place of theta I write beta minus alpha. In place of g value normal to the direction of the inclined plane is g cos alpha. So this value is given as t equal to 2u into sin of beta minus alpha by g cos alpha. So from this what we want here, u value. So u equal to gt cos alpha by 2 into sin of beta minus alpha is the equation for the velocity, initial velocity of the projection. So answer gt cos beta or cos alpha, here it is. Here gt cos beta is given. Gt cos beta by, so answer is for this one. So this is angle of projected and angle of elevation beta. So this is given as alpha in the data. So it is given as alpha in the data. This is given as beta. So this is correct answer for this given values. And for this values here, so if it is given as alpha, this one is given as beta. And for this values here, t equal to 2u into sin of alpha minus beta by g cos beta. So from this u equal to gt into cos beta by 2 into sin of alpha minus beta is the answer. So if you consider this one as alpha, this one as beta, but according to given data, angle of projection is alpha is given. So angle of elevation is beta. Angle of elevation is beta. So this is given as beta. For this values here, this is the equation for velocity of projection as gt cos beta by 2 into sin of alpha minus beta. So acceleration due to gravity in downward direction is g. Normal to the inclined plane is, when it is beta, here also it is beta. So it is g cos beta. So have to consider regarding time of flight of the projectile over inclined plane, then acceleration due to gravity along the direction of normal to the inclined plane. So along the direction of normal to the inclined plane, acceleration due to gravity component is taken as g cos beta. Instead of g, 2u sin theta by g is the basic equation on horizontal plane. On inclined plane, 2u sin theta. Theta value is the angle made by this projection with the inclined plane, alpha minus beta, by g into g value. So normal to the inclined plane, g cos beta. That is the basic equation for time of flight of the projectile. So answer is velocity of projection according to given data is gt cos beta by 2 into sin alpha minus beta is the answer for this question. So it is gt cos beta by 2 into sin of alpha minus beta. So for this values, this is the answer. For this values, this is the answer, and for this one, this is the answer. So according to given data, this is given value. Okay, so answer is gt cos beta by 2 into sin of alpha minus beta. Next question. A skier travels with constant speed 6 meter per second along a parabolic path y equal to x square by 20. Find the acceleration of the skier when he is at 10, 5. He is at coordinates 10, 5. Neglect the size of the skier. So when skier travels with constant speed along the parabolic path here, this is the skier here. Travels along the parabolic path with respect to center here, it moves with velocity v in the parabolic path of, here it is radius is r. So indirectly here it moves with constant speed. So indirectly it moves on the arc path with constant speed. So its tangential acceleration is 0. So on Skyer, tangential acceleration is 0. So Skyer will experiences only centripetal acceleration towards center, that is AC. So all of you know the equation for centripetal acceleration of the Skyer along this path is v square by r. So how you calculate radius of curvature of this parabolic path if its equation is given as y in the form of x. So if the path equation is given in the form of y and x here, then how you calculate the radius of curvature of that path, radius of curvature of that curved path. So all of you know the radius of, if the path of any curve is given, the path of any curve is given, for this path this is the curve, then you have to consider this is the curved path of, by taking this as the part of the circle, then this will give radius of the curvature. At this point velocity is v. Then here centripetal acceleration is AC. So for this path here, at this point coordinates are given as 10, 5 are given coordinates. So x coordinate is 10, y coordinate is 5 is given at this point. At this point velocity is v, radius of this imagined circle by passing through this part of the curvature is r. So when function of this curve is known to as y equal to fx, then the radius of the curvature is r equal to 1 plus dy by dx whole square whole to the power 3 by 2 by d square y by dx square. What is the equation for the radius of curvature of the curve is represented by a function y equal to fx. This is the equation. So for radius here what we want, acceleration of the Skyer, v square by r. V is given directly as 6 meter per second. How we calculate radius? 1 by r value. So what is 1 by r value? By reversing this value. So first y value is given as x square by 20. Y value is given as, here it is x square by 20. From that you have to calculate dy by dx. Then d square y by dx square. Okay, dy by dx, then d square y by dx square. So you substitute the values of dy by dx and d square by dx square in this equation, then you get, from this you get r value. You substitute r value in this equation, then a equal to, here v square 6 into 6 square by this r value is, r value at this point. So after differentiation, first differentiation, second differentiation of this given function with respect to x here, then you get the values in x and y. You take x value as 10 and y value, see the coordinates, x value as 10 and y value as 5. Then you get r value. You substitute r value in this equation. Finally you get answer 9 root 2 by 10. 9 root 2 by 10 units. So this is the process of calculation of the acceleration of the Skyer travels along the parabolic path represented by the equation y equal to x square by 2y. Then find the acceleration of the Skyer. It is when he is at 10, 5 coordinates. So it is the horizontal display x coordinate, this is the y coordinate, x value and y value. So when Skyer or any particle moves along curved path, so at any point how you find radius of curvature. So radius of curvature of any curved path whose equation is known to you in the form of y equal to fx, then r equal to 1 plus dy by dx whole square and whole to the power 3 by 2 by d square y by dx square. So y is given as x square by 20, you calculate dy by dx. From that again you calculate d square y by dx square. You substitute these two values in this equation, then you get r value. So what we want here, acceleration of the Skyer, v square by r. V value is directly given as 6 meter per second. So you substitute v value and r value in this equation. Finally you get answer as 9 root 2 by 10 units is the acceleration of the Skyer moves on parabolic path with constant speed 6 meter per second, and whose equation is represented as y equal to x square by 2 is given in the data. So with the help of this equation we can calculate the radius of curvature of the radius of curvature of that parabolic path at the given coordinates 10, 5. After calculation of this radius of curvature, you substitute this value along with the velocity as 6 meter per second in this equation. Then you get the acceleration of that sphere moves along this curved path represented by the equation y equal to x square by 20. Okay, so answer is 9 root 2 by 10 units is the answer for this question. Okay, for 16th question I think. Yes, 16th question. So answer is 9 root 2 by 10. Answer is B. It is another standard model question you have to kept in mind. Okay, that formula I have to kept in mind. So when the function of any curved path is given and known to you, how you calculate radius of curvature of that path at a given coordinates x, y. Here given coordinates are 10, 5. Okay, right. Next question number 17. The two particles 1 and 2 are projected with same speed v as shown in the figure. The particle 2 is on ground and particle 1 is at a height h from the ground and at a horizontal distance s from particle 2. If the graph is plotted between velocity of the particle and a distance s for the condition of collision of these two, and v value on y-axis and s value on x-axis, what is the nature of the graph? So when first particle is projected with velocity v along horizontal direction, at a depth h from this projection, another particle is projected with velocity v opposite to the direction of the projection of the first particle at a distance s. So now I considered the first particle is projected with the velocity. What is the relative velocity of the first particle with respect to second particle? V minus half minus v. So first particle is supposed to be projected with the velocity 2v. Indirectly you are considering relative velocity of the first particle with respect to second particle as 2v. Then second particle is to be taken at the same initial position at rest, that at that distance s. Now it strikes the second particle. So it is nothing but the range of the first particle as s, velocity of the first particle as 2v. So at what height it is projected horizontally? H. So when particle is projected with horizontal velocity 2v, that it strikes the ground at a distance s. This height is h. We know the relation. Here it is second particle, it is first particle projected. So we know that this distance s is equal to horizontal component of velocity into time of flight, root of 2h by g. When you send 2 under root, v into root of 8h by g is equal to s. We want vs relation. V equal to s into root of g by 8h. So g is constant, h is constant. So v directly proportional to s. That is v is equal to some m into some s, where m is the slope of the given graph plotted between v and s, because it is in linear relation. V and s are linear to each other. So nature of the graph is a straight line passing through horizon, v and s, and having slope root of g by 8h. So what is the nature of the graph plotted between velocity of this particle and distance of the second particle at the time of projection of the first particle? So v and s. The nature of the graph is a straight line passing through horizon and having slope root of g by 8h is the answer for this question. So what is the basic concept of relative velocity? Suppose when two particles are moving in opposite direction with the velocities v1 and v2, a and b. If you want to consider relative velocity of one with respect to b, so simply along same line, if first particle is supposed to be projected with the velocity v12, then indirectly second particle is to be taken at same position at rest. So if you consider velocity of the first particle with respect to b as v12, then second particle to be taken at rest at the same position. That I considered in this problem. If first particle is projected with the velocity v and second particle is projected with the velocity v in opposite direction at a distance s. So, the relative velocity of first particle with respect to second particle is taken as v12, that equal to v minus of minus v 2v. So, I considered velocity of the first particle as relative velocity of 1 with respect to 2, then I considered second particle at rest at a distance s. So, indirectly it is nothing but the body projected horizontally with certain velocity at certain height when it strikes according to given data, if collision takes place between these two. So, when it strikes the second particle, then the distance covered by the first particle is s, the vertical displacement covered by it is h, the time of flight is root of 2h by g. So, on that basis here I have written the equation as here s equal to velocity into time of flight, that is 2v into root of 2h by g, from that v equal to s into root of g by 8h. So, it is in the form of y equal to mx, because y on y axis here v values are taken, on x axis displacement values. So, we get a graph plotted between v and s is a straight line passing through origin. So, that is v equal to ms, m it represents the slope of this straight line and is given by root of g by 8h. So, answer for this one is B. It will be a straight line passing through origin and having a slope of root of g by 8h. Next, question number 18. A particle is moving in a plane with a velocity is given by u equal to u naught I bar plus omega a cos omega t j bar. So, indirectly this velocity is having two components, one along x direction, another having along y direction. So, horizontal component of velocity is u naught, vertical component of velocity is omega a cos omega t. Now, it moves in a plane. So, that is having both horizontal and vertical component of velocities. If the particle is at origin at t equal to 0, at t equal to 0, x component is x displacement is 0, y displacement is 0. Find its distance from origin after this particular time interval. So, indirectly when you know velocity, how you find the displacement of this particle? Simply u can be written as dx by dt along horizontal direction, that equal to u naught. So, dx is equal to u naught into dt for calculation of displacement along horizontal direction a given time interval is x equal to u naught into t plus some constant of integration c1. But at t equal to 0, at t equal to 0, this constant is also 0 at t equal to 0. In a similar way, uy can be written as dy by dt is equal to omega a into cos omega t. So, dy is equal to integral of omega a cos omega t dt. So, from this y is equal to omega a into for cos omega t sin omega t by omega into t plus some constant c. From this y equal to omega a into sin omega t by y plus some constant c2. So, at t equal to 0, this value is 0, y is also 0, therefore, y is also 0. So, c2 is also 0. So, from this y is equal to omega a sin omega t by omega. So, omega gets cancelled, y equal to a sin omega t, y equal to a sin omega t. Okay. So, this is the value y. And what is the equation for x here? X is equal to here, from this x is equal to u naught into t. So, x equal to u naught into t. What we want? When particle moves in a plane, so displacement is equal to square root of x square plus y square, that equal to square root of u naught into t whole square plus y square. So, what is the magnitude of y here? Magnitude is in the form of a sin omega t. So, its maximum displacement. So, or at t equal to what the value of time is given here, at t equal to 3 pi by 2 omega. You substitute t value as square root of u naught into 3 pi by 2 omega whole square plus y value as a into sine of omega 2 pi by t, 2 pi by t into t is it is 3 pi by 2 omega, 3 pi by 2 omega, this is omega, this omega gets cancelled, this omega gets cancelled, so 2 gets cancelled, 3 pi, sin 3 pi is minus 1, so therefore it is root of 9 pi square by 4 omega square into u naught square plus here minus a is there, sin of 3 pi minus a, sin of 3 pi is minus 1 into a, that is square, so that is a square. So what is the displacement of the particle at t equal to, it is 3 pi by 2 omega. Displacement of the particle at t equal to 3 pi by 2 omega is root of 9 pi square by 4 omega square u naught square plus a square. So 9 pi square u naught square by 4 omega square plus a square. So answer is A for question number 18. So when velocity equation is given, from that you calculate displacement equations. Just by taking horizontal component of velocity as ux, from that dx by dt. By taking vertical component of velocity as uy, from that we calculate dy by, from that we take it as dy by dt, from that we can calculate vertical displacement. So when particle moves in a plane, the displacement of the particle after t seconds, when it moves in a plane, is given by root of x square plus y square at a given particular time interval, that is 3 pi by 2 omega. So after calculation of this x and y values at a particular time intervals t equal to 3 pi by 2 omega, then we get this value as minus a whole square, that is a square, and this value as 9 pi square by 4 omega square into u naught square. So this is the answer for this question. Answer is A for question number 18. Question number 19. For a particle moving along x-axis, which of the following velocity versus position graph gives? The option below is possible. Particle is moving along x-axis. It's a velocity versus position graph. Particle is continuously moving along x-axis. Particle continuously moving along x-axis means it never return back to its initial position. It never return back to its initial position means here as x increases, the direction of velocity never changes. Direction of velocity never negative. So here on that basis we have to take the answer. So particle may starts beyond origin or just above origin, so that we may consider. But once particle is started, continues to move along x direction, moving along x direction continuously. So indirectly, as continuously, displacement of the particle increases. So as x value increases means the direction of the velocity never be negative. It doesn't change its direction of velocity. The direction of velocity may be in the same direction at this point or at this point, whatever may be the position, so velocity may be in the same direction. So on that sense, you have to take the answer. So for option B, so after sometimes velocity is negative. After some time again velocity is positive, so it is wrong. For option C here after some time velocity changes from negative to positive, again from positive to negative. It is also not possible for a particle moves along continuously, moves along x-axis. So only this is the possibility. So suppose velocity is in this direction, velocity is negative to continuously in this direction, slope is same. So slope is, so in this case dv by dx is same. So continuously it may move. As x increases, velocity may increase, direction of velocity may be the same way. So it never changes. So answer is A for question number 19. So 19th question answer is A. Question number 20. A particle moves with constant speed u along the curve y equal to sin x. So when it is compared with y equal to a sin omega t. So here a amplitude is 1, omega t is equal to x. So omega into t can be written as dt is equal to dx. So dx by dt can be written as omega. So dx by dt can be written as omega. So okay, now what we want? the magnitude of its acceleration at the point corresponding to x equal to pi by 2. At x equal to pi by 2 means indirectly particle is at extreme position. At path difference equal to, here phase difference is pi by 2. Phase difference is pi by 2, indirectly it is at extreme position. At extreme position means when it represents y equal to sin omega x, indirectly it is in simple harmonic motion. When particle is at extreme position, then acceleration is equal to omega square into its amplitude. So this amplitude is 1 here, 1. What is omega here? Dx by dt. Dx by dt whole square equal to a. Okay. So, but dx by dt is velocity of the particle, that equal to u square into 1. So, acceleration of this particle is u square is the answer. So, u square by 2 is there? No. C is the answer. U square is the answer for acceleration of the particle. Okay. So, for question number 20, answer is, but it is also having meter per second square, but some terms are there. So, amplitude term is there, and in this case dx by dt term, omega term is there. So, for that here don't consider this u square velocity square dimension which doesn't coincide with the dimension of acceleration. This is just a numerical number only. Okay, numerical value only. U square, suppose u is 10, 10 into 10, 100, a is 100, not the quantities representation. Okay. So, here meter per second square is the unit of this quantity for this number. So, u square is a number here only. Okay. So, for question number 20, answer is C. Question number 21. A particle P is projected from point on the surface of the smooth inclined plane. Simultaneously, another particle Q is released on the smooth inclined plane from same position. P and Q collides on the inclined plane after 4 seconds. Then speed up the projection of point P. So, when particle is projected from a point on the surface of the smooth inclined plane, simultaneously another particle Q is also released on the smooth inclined plane. After some seconds, t equal to 4 seconds, this P collides Q. This P collides Q. Then speed of the projection of the particle is that we want. So, when it is projected means like this. At the same time this Q reaches. This is the velocity of the projection. So, indirectly when it moves, even though it is projected with this velocity, here it moves due to gravity. Due to gravity it moves along this path, parabolic path, and strikes Q at this point. So, this time of flight is given as t, that equal to 4 seconds. So, what is the basic equation for body projected down from an inclined plane? Body projected down from an inclined plane, that is equal to time of flight is equal to 2u into sine of, when it is projected down, this one. Here it is. This angle is, here it is. So, from this it is projected at an angle alpha, this is beta. Angle of projection is always to be taken with respect to horizontal. At point of projection, body projected with horizontal is known to as alpha. Then the angle made by this horizontal with inclined plane is beta, suppose it is beta. Then with respect to the inclined plane, the angle of projection of the body is alpha plus beta. So, therefore, 2u into sine of alpha plus beta by g into sine beta. This is the equation for time of flight of the body when it is projected down from top to bottom of the inclined plane. At the same time, second body is moved along the smooth inclined plane according to given data. Both will collide at this point after 4 seconds. Therefore, 4 is equal to 2u into sine of, according to given data, first one is projected normal to the direction of the inclined plane. So, indirectly alpha plus beta value is given. Alpha plus beta value is given as 90 degree indirectly. So, for generalization, I considered if it is projected at an angle alpha with horizontal and angle of inclination is beta. So, angle of projection of this particle with respect to inclined plane is alpha plus beta. But according to given data, first particle is projected normal to the inclined plane. So with respect to inclined plane, angle of projection is 90 degree. That is alpha plus beta value is taken as 90 degree. So it is sin 90 degree by g into sin beta. So what we want here? What we want according to given data? So speed of the projection. This angle is given as 60 degree. Beta value is given as 60 degree. So 4 equal to 2 into sin 90, that is 1 by g 10 into sin 60 degree. So from this you calculate u value, and u value is out of this one. So answer is B after calculation. Do the calculation, 10 meter per second is the answer. So answer is B for question number 21. So it is another important standard model question regarding the projection of a body on inclined plane. So for body projected down from top to bottom of the inclined plane, here angle of projection is taken as 90 degree. So for general formula for time of flight of that body projected down from top to bottom of the inclined plane is generally, it is alpha plus beta for downward projection. For upward projection, for time of flight, it is 2u into sine of alpha minus beta. It is for downward projection, alpha plus beta for downward projection. So the alpha plus beta value is given indirectly as 90 degree. Okay, because first body is projected normal to the direction of inclined plane. At the same time, second body moves down along smooth inclined plane. Then if both collides after 4 seconds, then indirectly nothing but the time taken by first body to collide second body is nothing but time of flight, that I have written. T equal to 2u sin of alpha plus beta by g into cos beta, where beta is the angle of inclination of the inclined plane. Okay. So answer is, after calculation we get answer as here 10 meter per second. Next, question number 22. Two particles A and B are separated by a distance 2r are moving counterclockwise along with the same circular path of radius R, each with uniform speed v. At a time t equal to 0, A is given a tangential acceleration of magnitude A equal to 72 v square by 25 pi r. Then what we want? See the options. The time lapse for the two bodies to collide, the angle covered by A is, angular velocity of A is, radial acceleration of A is, that we need. So time for collision, that we have to calculate, and angle covered by A during this collision, and angular velocity of A while it collides B with B, radial acceleration of A, that we have to check. So two particles are moving in counterclockwise direction, separated by a distance 2r indirectly, both are at the ends of the diameter of the circle. So okay, 2r and r2r. So this is particle B, this is particle A. So initially both moves with speed v initially, moving in counterclockwise direction, each with uniform speed v. Okay, at t equal to 0. But here A is given as a tangential acceleration 72 v square by 25 pi r, then it has to move fastly when compared to B. Finally, A supposed to collide B at this point. So A when after giving tangential acceleration of certain value to A, that is 72 v square by 25 pi r, then it moves along this path and finally it collides B at this point. So this is the position of collision of A and B. So this we want, this angle we want, this theta we have to calculate. In this case here, this angular velocity of A we have to calculate. This is A, this is B. Initially both are having same linear velocity at t equal to 0. At that time, at t equal to 0, it is given as tangential velocity, tangential acceleration as, what the value here, 72 v square by 25 pi r. 72 v square by 25 pi r, where r is the radius of the circular path. So both supposed to collide at this point. This equation is theta. So this is the point of collision of A and B. Let B takes t seconds to reach this point. Let B takes how much time? T seconds. B takes t seconds to reach this point. At the same time, A also collides B. So time of collision is t seconds. Time of collision is t seconds. So what is the distance covered by B in t seconds? Distance covered by B is, because it moves with constant speed v on circular track for t seconds, the distance covered by this one is nothing but arc length, nothing but velocity into time. So equal to distance covered by A with respect to B. With respect to B, what is the distance covered by A? So it is to be moved with acceleration starts from initial velocity. So Vt plus half At square. What is At square? 72 V square by 25 pi r whole square, half A into t square. With respect to position B, A lags by a distance of pi r. So minus pi r. This is the distance covered by A with respect to B. With respect to this position, B covers this distance. So A also to be considered with respect to position of B for collision. So with respect to this position, it is a lag of distance, lag of pi r. So with this acceleration, it covers a total distance. This is the distance, but lags a distance of pi r with respect to initial position of B. So here Vt gets cancelled. Vt gets cancelled. From this, do the calculation. After calculation, we get t value as 5 pi r by 6v. Do the calculation. Okay. So this is the displacement covered by B in a given time interval. Okay, Vt. At the same time, the displacement covered by A is this one that I have written. With respect to B position, I consider this displacement. With respect to B position, this is the displacement covered by B. With respect to B position, displacement covered by A is ut plus half A square minus of this distance. Minus of this distance. So here this value is written with respect to B position, because the displacement covered by B with respect to B position is Vt. For A, this is the total displacement, minus of this distance will give. It is also displacement of A with respect to position B. Okay. So for that reason, by equating these two, we get, after calculation, t equal to 5 pi r by 6v is the time of collision. Okay. Now what we want, next point, time lapse for the two bodies to collide is 6 pi r by 5v. 6 pi r by 5v. No, it is 5 pi r by 6v. First option is wrong. Second option, angle turned by A is, what is angle turned by A? Angle turned by A equal to omega into t. So omega into t. What is omega here? Omega into t is 5 pi r by 6v. 5 pi r by 6v. Okay. Or omega is not known to you. So angle turned by A is equal to this pi radian, this pi radian, angle turned by A, pi radian plus this extra value that theta. So pi plus theta equal to, generally this arc length is known to you Vt. Arc length is known to you Vt. So how you find theta? So arc equal to radius into angle theta. Radius into angle theta. So theta equal to arc length by radius. What is arc length? Vt by radius is r. So pi plus Vt by r. So pi plus V by r into t value is 5 pi r by 6v. So V gets cancelled. After calculation, we get it is 11 pi by 6. So what is the angle turned by A? Angle turned by A, pi plus this theta. Theta is written as arc length equal to radius into theta. Theta equal to arc length by radius. So this arc length is Vt by r. So V by r into t value is given as 5 pi r by 6v. So after calculation, we get 11 pi by 6 is the angle turned by A during collision. So answer is 11 pi by 6 is the answer. In a similar way, later whenever you know theta and time, you can calculate angular velocity. What is the angular velocity here? Angular velocity of A equal to omega into, this is the omega into t. So omega equal to theta by t. You know theta value 11 pi by 6. You know t value. So from this, what is the angular velocity of A? That equal to theta A by t. You substitute theta A value and t value in this equation, then you get angular velocity. That is also not matched with this one. So at the same time, radial acceleration of A, v square by r. You know velocity, you know r value. So from that, it is also not matched. So out of all this, only angle turned by A is 11 pi by 6 and time of collision is 5 pi r by 6, but it is given reversely. So this is the another important model question. What is the key point of this question? This is the key point. With respect to the position of B, the distance covered by B is Vt. With respect to position of B, distance covered by A is half Ut plus half At square minus of this distance, because I am going to calculate the distance covered by A with respect to position of B. So by equating these two, we get the time of collision of these two, that is 5 pi r by 6v. Okay, so this is the explanation for this question. Question number 22, answer is B. Next, question number 23. It was calculated that a shell, when fired from gun with constant velocity at an angle of elevation 5 pi by 60. A shell was fired from gun, certain velocity at an angle of elevation 5 pi by 36. Okay, strikes a given target. Next, in actual practice, it was found that a hill just prevented the trajectory. Hill just prevented the trajectory like this. Okay, at what an angle of elevation should the gun be fired to hit the target? Here it has to fire like this. For same range, the shell to be projected at an angle 90 minus theta for same range. So it is nothing but it is to be projected with a complementary angle 90 minus theta. So at what an angle it is to be projected? Tell me. 90 minus theta. That is 90 minus theta value is 5 pi by 36. Therefore theta dash is equal to pi by 2 minus 5 pi by 36. So after calculation, we get at what an angle shell is to be projected to hit the target, even though some hill is there in its trajectory, is 5 by 2 minus 5 pi by 36. So after calculation we get 13 pi by 36. 13 pi by 36 is the answer for question number 23. Question number 24. A person throws vertically n balls per second with the same velocity. He throws a ball wherever the previous one is at its highest point. The height to which ball will rise. So a person throws vertically n balls per second with the same velocity. All balls are projected with the same velocity u. He throws a ball whenever previous one is at highest point, second one is ready to project. So indirectly here the time of flight of this one, is, so for 1 second how many balls are projected? N balls. So time for one ball is equal to, it is time for one ball is equal to 1 by n second. So time taken by the ball to reach its maximum height is 1 by n second. Then only next ball is ready to project. Indirectly, this time of ascent of each ball is given as 1 by n second. What is the time of ascent of each ball? U by g equal to 1 by n. So from this u equal to g by n. So what we want? Height reached by each ball. So height reached by each ball equal to h equal to u square by 2g. U value is g square by n square into 1 by 2g. So from this g by 2n square is the maximum height reached by each ball. G by 2n square is the height reached by each ball. So, a person throws n balls per second with the same velocity. He throws a ball whenever the previous one is at highest point. So, when he throws n balls in 1 second, time to throw each and every ball to reach maximum height is 1 by n second. Indirectly, time of ascent of each ball is 1 by n second. When you know time of ascent of projection of each ball, that is equated to u by g equal to 1 by n. From this, u equal to g by n. So, what we want? What is the maximum height raised by each ball? So, nothing but maximum height of the vertically projected body is u square by 2g. So, u value is g square by u square is g square by n square into 1 by 2g. So, g gets cancelled, we get g by 2n square is the maximum height reached by each and every ball. Most important question it is. So, answer is C, g by 2n square. Next question. For an observer on trolley, the direction of the projection of the particle is shown in the figure. While for observer on ground, ball rises vertically. The maximum height reached by the ball from the trolley is. So, trolley is moving horizontally with velocity 10 meter per second. Trolley is moving horizontally with velocity 10 meter per second. Okay. So, ball is thrown from the trolley with velocity v. So, ball is thrown with velocity v with respect to trolley. So, v is the velocity of the ball with respect to trolley, and it is thrown at an angle 60 degree with horizontal. So, what is the vertical component of the ball here? Vertical component of the ball is here with respect to trolley is, here it is 60 degree. So, it is v sin 60 degree is the vertical component of the velocity of the ball with respect to trolley. This velocity is 10 meter per second, velocity of the trolley. Okay. Now, when body is projected with the velocity u at an angle theta with horizontal, we know that maximum height reached by the body equal to u square sin square theta by 2g. So, what is sin square theta here? Vertical component of u square sin square theta is that the square of the vertical component of velocity by 2g, 2 into acceleration of the body in vertical direction, that is uy square by 2 into ay. So, but trolley is not having vertical motion, only it is having horizontal motion. So, this maximum height reached by this ball, was not affected by this horizontal acceleration. So, due to that here, directly I can consider the maximum height reached by this body when you know vertical component of velocity of the body, even though the trolley moves horizontally on the track. So, you know velocity as given as for the value here. So, v cos 60 along horizontal direction, v cos 60 is equal to 10. So, v equal to 10 by cos 60, 1 by 2, that equal to 20 meter per second. When you know velocity as 20 meter per second, that equal to, here it is u. So, maximum height reached by this one equal to, here it is v square sin square 60 by 2g. So, 20 square into sin 60 root 3 by 2 whole square by 2 into 10. Do the calculation. After calculation, you get answer as, here it is, answer as 15 meters. So, maximum height reached by the ball is 15 meter is the answer. Answer is B for question number 25. So, if this vehicle is having vertical motion instead of horizontal, then maximum height reached by that body or ball or this projected body will be varied. So, the maximum height reached by a body projected at certain angle theta with horizontal depends on vertical component of its velocity of projection. But here only trolley is having horizontal component of velocity. So, trolley is having only horizontal motion. So, there is no vertical velocity of the trolley. For that reason, the maximum height reached by the ball was not affected by this horizontal motion of the trolley. For that reason, I take direct equation for calculation of maximum height reached by this ball. So how you calculate velocity of the ball? The component of this ball along this direction, horizontal direction, is equal to trial velocity. So from this I calculate velocity of the ball as 20 meter per second. Now you substitute v value as 20, theta as 60 degree, g value as 10. From that you get 15 meter is the maximum height reached by this ball projected at an angle 60 degree with horizontal in a trolley, moves with horizontal velocity 10 meter per second. So for this one answer is 15 meter. Question number 26. A bird flies with a speed of 10 km per hour and a car moves with a uniform speed 8 km per hour. Both starts from B towards A. BA equal to 40 km at the same instant. The bird having reached A flies back immediately to meet the approaching car. As soon as it reaches the car, it flies back to A. The bird repeats this till both car and bird reach A simultaneously. Then total distance flown by the bird during this time is. So in this case here it is B, car and bird. It is B, it is A. The destination between B and A is 40 km. So when car moves with speed 8 km per hour. So what is the time taken by the car to reach A? Time taken by the car is equal to is the total distance by speed 8, that equal to 5 hours. So in 5 hours bird reaches A, again come at this time car is at this position, bird come back to A. Again it goes to A, then again come approaching towards car. Like this, as bird reaches A, again approaching towards car. Like this, after some time both car and bird reaches point A simultaneously. So in this time interval, as car moves from B to A continuously, bird reaches A and approaching towards car, and again moves towards A and approaching towards car. Like this, bird shuttles in between car and destination A continuously until this car and bird reaches A simultaneously. So indirectly, what time car will take to reach point A, that will be the total time taken by the bird to reach A during its number of flies. So due to that, here time taken by bird is equal to, so time taken by car, that equal to 5 hours. In 5 hours, what is the displacement covered by bird? Velocity of the bird into time taken. What is the velocity of the bird? 10 km per hour. So 10 km per hour into time is 5 hours. So it is 15 kilometers. So during this number of flies here, what is the horizontal distance covered by bird before both reaches A is 50 km is the answer. Very simple. So time taken to car to reach A is, time taken by the car to reach A is 5 hours. In this time, bird flies number of times. Bird flies number of times in between car and this destination. But whatever may be the number of flights in between car and destination by the bird here, the total time must be 5 hours. In that time, what is the constant speed of the bird here? According to given data, bird has to fly with constant speed. So that is 10 km per hour. So 10 multiplied by 5, that will give 50 km is the total distance covered by bird during this number of flights in between destination and car in this entire journey. So answer is 50 km. Answer is C for question number 25. Question number 27. A body A begins to move with initial velocity 2 meter per second and continues to move at constant acceleration A. At delta t equal to 10 seconds after the body A begins to move, a body B departs from the same point with initial velocity 12 meter per second and moves with the same acceleration. So what is the maximum acceleration A at which body B can overtake A? So here from certain point here, A moves with initial velocity 2 meter per second and continues to move along this path. So after 10 seconds, body B begins to move along same path B. The speed 12 meter per second with same acceleration. Then so after some time here, Here A is suppose at this position, B is at the same position, so it has to overtake. In this case, with what relative velocity of this body here? With what relative velocity of these two bodies, B will move with respect to A. So 12 minus 2. So in the given time interval, both are moving with same acceleration. So relative acceleration is 0. Relative acceleration is, so with what acceleration it moves, with what acceleration it moves, it will be same for both. So in this case, acceleration of this body is equal to V minus U by given time interval delta t. So here this can be taken, so it moves with constant speed. It starts with speed 12 meter per second and reaches B dash in overcoming A dash after this time interval. So now I consider this one as 12 meter per second as final velocity of this one with respect to A and B. If I considered B with respect to A, then this velocity is taken as V and this velocity is taken as U. Time interval is given as 10. So it is 12 minus U value is 2 by time interval is 10. So that is equal to 10 by 10. That is equal to 1 meter per second square is the acceleration at which both has to maintain, so that even though B starts 10 seconds after starting motion of the body A at one particular point A along straight line, then both has to cover with an acceleration 1 meter per second square. So this is the explanation for question number 26. So answer is 1 meter per second. 27. Answer is 1 meter per second square. So these are the important questions regarding the chapters physical world, straight line motion and motion in a plane. So out of all +1 syllabus here, these three in these two chapters, that is especially straight line motion and motion in a plane, consists a lot of mathematical calculations. These mathematical calculations will play a vital role in understanding the concepts of laws of motion, work power energy and rotation. Okay. So this is the explanation of all these 27 questions regarding the topics physical world, straight line motion and motion in a plane. Okay. Right.
+2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം. +2 ഇംഗ്ലീഷ് എക്സാമിന് മികച്ച മാർക്ക് വാങ്ങാം മികച്ച അധ്യാപകർക്കൊപ്പം. മാർച്ച് 18 കൃത്യം 5 മണിക്ക് റൈസിന്റെ യൂട്യൂബ് ചാനലിൽ +2 ഇംഗ്ലീഷിലെ പ്രധാന ഭാഗങ്ങളുമായി ഞങ്ങളുടെ അധ്യാപകർ ലൈവിലെത്തുന്നു. അപ്പോൾ എല്ലാവരും ഉണ്ടാവണം, നമുക്ക് ലൈവിൽ കാണാം.